this video, we will be writing the code to the problem strip tree of March Lunchtime 2020 Codechef. I have discussed the solution to the problem strip tree in the other video. You can find the link in the description. So let's get started with the code. I guess you are all aware and familiar with this library. It includes all the headers in your file, right? So you did not worry about the headers, right? All right. So let's write the main function. So we are given some test cases t, and for all those test cases, we are given an integer value d, which is denoting the depth, right? So let's first of all get the total number of, and let's first of all find out the number of nodes in the tree, right? So let's say it's n, the number of nodes in the tree. So it is nothing but 2 raised power d plus 1 minus 1 as discussed in the solution, right? So we need to write a power function. We will write it here, right? Which will take a variable a and a variable b, right? Now if b is 0, we will simply return 1, right? If b is 1, we need to return a, all right? Otherwise we will use a temporary variable to store the power of a b by 2, cause we will be using divide and conquer strategy to compute power in order of log n time, right? So if b is even, right, then in that case we will return temp time temp, right? And otherwise, that is the odd case, we need to return temp times a times temp, where a will make it a odd product, right, for b being odd, right? But in the problem we are given that we need to compute all things modulus 10 to the power 9 plus 7. So let's define a mod variable which is 10 to the power 9 plus 7, right? All right. So let's take the mod of these as well. Temp this mod. So temp into temps mod, we need to take, and here we need to take mod of these two products, right? And then we will take mod of this whole product, right? All right. So this is the power function. Let's also define the mod inverse function, that as I have discussed using the Fermat's little theorem. So for a number a, all we need to do is return power a mod minus 2, right? Modulus mod. This is all we need to do for modulus inverse using the Fermat's little theorem, provided that mod is a prime number, right? Which is in our case, right? So we got n. So what are the total number of favorable cases? Total number of cases. Let's say it as TOT variable, right? So it is nothing but n times n minus 1 times 2, as we have discussed, right? So cause n is a very large variable, we need to take modulus here also, right? All right, and then we can take its whole modulus. All right. So now we need to compute the number of favorable cases. We have computed total number of cases to be considered. Total number of favorable cases, as we have told, it depends on the depth. So we will go this way. for 1 to d. Let's define a favorable variable here, long int favorable, which is 0, right? And let's define a variable long int count power 2 comma d, 2 raised power d, right? And now there are two cases. If d mod 2 is 0, that is even case. For even case, we know that long ancestors that are good for our case will be e by 2, right? And for the else case, that is d is odd, let's suppose the ancestors will be d plus 1 by 2, right? As we have discussed in the solution part, right? So here the favorable will be incremented this way. Favorable equals favorable plus this thing 2 times ancestors time the number of nodes in that level, that is count. Again, the modulus operation comes is necessary, so we will take this whole modulus, right, and modulus of this as well. All right, we should take modulus of this also and whole mod. So to save time, I will copy this piece of code here, and the only thing we need to change, no, nothing, we need to change nothing here because the ancestor variable is already changed in these two statements. So now all we need to return or print is favorable times mod inverse so it will be mod inverse of TOT, right? And we will take its modulus as well, this whole modulus. So this is all, I guess, for the answer. Let's run for the sample test and check whether it is working for it. If it is working fine, we will submit this code. So there is a compilation error which says invalid operands of type long to double and double to binary operator. Alright, so this will be treated as a double variable. Right, so we will replace this with 10 to the 9 plus 7. Let's run this code now. So it successfully executed. But we are not getting the right answer for the second case. Let's see. Oh, I'm so sorry. Actually, all these should be I, right? All these should be i's because we are iterating over 1 to d using this I variable, right? So now I guess this should work fine. Yeah, it is working fine. Let's submit this code and check whether it is working completely fine on the complete test set or not. So this is quite a simple problem, right? So you can see this is completely correct. We got a AC as a result. You should all must try this problem. It's a good one. So bye bye. Thank you for watching.